Are you tired of dealing with messy scanned PDF invoices with endless data entry? Today, with the help of VBA, we are transforming Excel into an AI powerhouse ready to read and extract precise data from any invoice you throw at it. Get ready to automate the impossible. Let's go straight to the demo. Here's the scenario. Imagine you have a folder filled with dozens or even hundreds of PDF invoices, each one from a different supplier, with varying layouts, different terms for total amount, and supplier names scattered all over the page. Manually extracting the invoice number, date, supplier, and total from each one of them would be prone to human error and take an eternity. And writing a program to cater to every possible scenario out there is just impractical. But we've got an AI-powered automation. The PDFs that we're going to extract are on the screen. They're fairly standard for now. Watch this. Let's run the macro. And just like that, column A, B, C, and D are automatically populated with the invoice number, date, supplier, and total amount, extracted perfectly from every single PDF invoice. But this was an easy example. They were just computer-generated PDFs, not a big deal. Let's give a chance for the AI brain behind our macro to really shine. What if an invoice comes along, perhaps a scanned one, or one with a completely new layout? In fact, check out this invoice. I don't know if you can see it really well. I'm going to paste a picture of it on the screen. I have literally written it out by hand. And observe the photo image on the screen. I have purposely left my shadow in there for some distortion. The question now is, do we need to rewrite any of our code to account for this new scenario? Not at all. Because we're using a large language model with image understanding capabilities, it adapts. It reads the document just like a human would, interpreting the context and the layout, even if it's visually complex or just a flat scan. Let's run it again with this new tricky invoice in our folder. And notice I'm leaving the old PDF invoices along with this new scanned copy in the same folder just to show that we can process multiple formats in the same batch. Let's run a macro. Great. The new invoice is processed flawlessly, fitting right into a structured Excel sheet. The macro adapted in real time without a single change to the VBA code itself because the AI is doing the real heavy lifting of the interpretation. And the applications for the core idea behind this project are limitless. We are living in exciting times, and it's time our skills evolve too. Next, we are going to spend some time discussing how the solution has been put together. But if you want to jump straight to the build, just look for the right timestamp in this video. Before we dive into the code or the solution, let's talk about the state of AI today because it completely changes how you should approach this video. When I say AI in this context, I'm really talking about large language models or LLMs. So basically ChatGPT or Gemini. On a high level, LLMs are basically a super advanced brain trained on a massive library of text, images, and code. And a specific trained version of this brain is called a model, like the Gemini 2.5 Flash model that we will be using today. These models are extremely good at understanding context, patterns, and human language, and they're also fantastic at generating code. This brings us to a huge shift in how we build things. We are now in the age of co-creating with AI, and our role as developers and problem solvers is evolving. The focus should be less on memorizing syntax of code such as VBA and more on the big picture, which is the core idea, the high-level setup, and the future possibilities. And treat AI as the partner in writing the actual code, or in fact, as a partner in every step of the solution. So how should you consume this video? Don't get bogged down trying to follow every line of code. Yes, I'll definitely explain things, but not to the detail as in my previous videos. The real value here is in understanding how this project was pieced together and why we chose the specific tools that we're using. The entire project code is available to you from the link in the description below. And here's the modern way to learn from it. Download the code from the GitHub link, copy and paste a line of code or a function or even the whole project into Gemini or even ChatGPT, and then ask it questions. Treat the AI as your personal tutor. For example, you could ask, can you please explain this subroutine step by step? What are the potential bugs in this code and how would you add error handling? And modify the script to add, say, payment due date. By doing this, You're using AI to do the heavy lifting, allowing you to focus on the strategic part of building the solution. This is the new skill set. And next, let's talk about the high level flow. Our solution works like an automated assembly line with Excel's VBA acting as the central orchestrator. Let's walk through the entire process from file to data. So first off, why build this in VBA? The answer is accessibility and integration. Invoice processing is a core business task and Excel is the world's business application. And by using VBA, the programming language built directly into Excel, we can create this powerful automation in an environment that millions of people already have. VBA acts as the glue that holds our project together. It calls each specialized tool when needed, manages the flow of data, and delivers the result right where we need it. That is, in an Excel sheet. The process begins when a VBA script scans a folder named invoices for any new files. Our logic is built to handle common formats like PDFs, PNGs, and JPEGs. If the file is already an image, it's ready for the next step. But if it's a PDF, we perform a crucial standardization step using a powerful free tool called GoScript. So you will be required to download it to make this project work. Our VBA script will call GoScript to convert the PDF into a high quality PNG image. So now the question is, why convert PDFs to images? This creates a universal format for the AI. Some PDFs, as we have seen in the demo, are just scanned images with no selectable text. And by turning every document into an image, we allow our AI model to see the invoice just like a human would, interpreting the visual layout to understand the context. This single robust approach works for all invoice types, structured PDFs, scanned PDFs, and native image files, and we don't need to change our core logic. Next, with a standardized image in hand, VBA sends it over the internet to the Google Gemini API. This is the brain of our operation. And here's why we use an AI model. It understands unstructured data. Traditional code would require rigid rules for every possible invoice layout, which is not practical. However, an LLM like Gemini understands context. We simply send the image along with a text prompt like extract the invoice, date, supplier, and total amount in JSON format. The AI analyzes the image, identifies the requested information regardless of where it appears on the page, and structures it for us. And we will use the Gemini 2.5 Flash model because it's fast, affordable, and excellent at understanding visual documents. Now, Gemini will send the structured information back to us in a format called JSON, which is short for JavaScript Object Notation. Since VBA can't read JSON by default, we use a free library called JSON Converter, which is again something you'll need to download from GitHub to make this project work. This tool acts as a translator, allowing our code to easily access the data fields returned by the AI, like invoice number and total. And with the clean data now understood by VBA, the final steps are simple. We'll write it to Excel. The script will populate a new row in our invoices worksheet with the extracted data. So in short, VBA finds a file, uses GoScript if needed to create a standard image, sends it to the Gemini AI for intelligent analysis, uses JSON converter to translate the response, and writes the final clean data directly into Excel. Let's take a quick look at our folder structure. It's pretty straightforward. We have a main folder here called invoices. This is where all our invoices will go. Our final code is going to be versatile, so we can draw both PDF invoices and images in the same folder. And we have a done folder. After our script successfully processes a file, it will be automatically moved here. Now let's open Excel. This is a blank workbook with a single sheet called invoices. Let's go to the VB editor, Alt F11. I have two modules out here. This invoice header extractor is going to be our main module, and we'll use the other one just to store our API key. We don't have any code in here yet. We're going to build everything from scratch, but I've gone ahead and created two constants, which are basically our folder paths. Let's start by creating the main subroutine. I'm going to go ahead and declare a bunch of variables that we will be using within our project. Here we have declared variables to handle the file paths, the API response, and the final extracted data. Before we start looping through the files, we'll call a helper subroutine to prepare our Excel sheet. This sub will clear all the old data and set up the headers in row 1. So let's declare the worksheet variable and reference our invoices worksheet. Let's clear all the existing content from the worksheet. Now let's set up the headers in our first row. We could add them individually or do it in one go through an array. We want the invoice number, date, supplier, total. To separate them from the extracted data, we'll just make the headers bold. And finally, we'll apply specific number formats to each column to ensure our data is displayed correctly. So column A will have text, B will format as a date, C will be text as well, and D will format as a currency. Now let's call this sub from our main sub. Now we'll initiate the file processing by getting the first file from our invoice folder. We'll use the dir function. Our path name will be the invoice folder, and we're searching for any file. So the name of the first file found will be stored in this variable. With the first file in hand, we can set up our main processing loop. We'll use a do while loop. As long as there is a file to process, which means as long as the file name is not an empty string. Once we process the first file, we'll call the next file. We can do that by calling the dir function again without submitting any arguments. And when there is no more files to process, the dir function will return an empty string and we'll exit the loop. Now let's move into our loop. First, we need a way to identify the current file's extension. That's because we have some additional logic that we will implement for PDF invoices. We'll save the extension in this variable and use a bit of string manipulation. So we want to find the last dot in the file name, which we can do using the inString reverse function. We'll use the len function to calculate how many characters there are after the last dot. We'll use the write function to extract just these characters. And just to be consistent, we'll make everything lowercase. Okay. Next, let's create the full file path. So this is the folder path and the file name. Okay, now that we have identified the file's extension, we will use a select case block to determine what set of actions to take. This will be a very clean and efficient way to handle different scenarios based on a single variable, which in our case is the file extension variable. So we'll have one scenario for PDF, another set of scenarios for image files. And if there's any other file, we'll catch it using the case else statement. Okay, that completes our select case structure. We'll now proceed to fill in the specific logic for each of these cases, starting with the PDF handling. For a PDF file, our first step is to convert it into a PNG image. We will use a powerful open source tool called GoScript for this. If you don't have it, you will need to install it. Let's come to the official GoScript website. Click on download. We want the PDF interpreter. Download and install the 64-bit Windows version. And please do your own research before downloading anything that I suggest or anyone else does. Go through the installation steps. I've already installed it on my computer. We need to grab the installation path for the executable. Yours will be in program files, GS, whatever version that you have. Go into the bin folder. We want the one that says 64C. Let's grab the file path. And now let's declare a constant for our Go script executable path. Paste in the folder path, followed by the file name. So this constant holds the exact location of the Go script program's executable file on our computer. And you must update this path to match your own Go script installation. And notice we are using 3 double quotes around the path to ensure that the entire path, even if it contains spaces such as these, is treated as a single unit when the command is executed. Now let's build a conversion subroutine. So it'll be a separate sub. So its job is to convert a PDF file into a PNG image using the Go script application. It will take 2 parameters. This is the full path of your input PDF and the full path of the generated PNG file. But before we dive into the VBA code, let's talk about how we'll run Go script. Go script is a command line program, which means we interact with it by giving it a specific text command. And the best way to build and debug these commands is to first get them working in a computer's command prompt. So let's start with constructing the command that we need. So first, we need the path to the executable file, which is this right here, copy. So we want to execute the command in command prompt. But before we do that, let's type out the full command in Notepad++, because visually it's just easier to manage this in a multi-line scenario. Okay, so first off is the command itself, which is the full file path wrapped in double quotes. We need to add in some more details to make sure that the output is in the format that we want it to be in. We'll do this on another line. And in command prompt to move to another line, we would need a caret symbol. So let's just add it out here. I'll type out the first set of options and then tell you what it is. These will tell Go script to run automatically without pausing for user input and to exit once the conversion is complete. This specifies that the output file should be a PNG image with full 16 million color depth, ensuring high quality. This option sets the resolution of the output PNG to 200 dots per inch or DPI, which is a good balance for clarity for the AI while keeping the file size manageable. And now we will tell Go script where to save the newly created PNG file. This option will take 2 arguments. First, the output file path. So let's grab the folder where the invoices were saved. And we'll just choose this first invoice. This should be the output file name, which will be PNG, and then space, and the input file name, which will be a PDF. Okay, that looks good. Let's copy. We can search for command prompt in our Windows search bar, or just press Windows R, type in CMD. That's a command prompt. Control V to paste in the command. That's fine. And enter. Okay, we didn't get any errors. So let's go and check out our folder. And an image file was generated. Let's click on it. That looks good. Let's delete this file and go back to the VB editor. Now it's time to construct the command prompt command as a VBA string. Let's declare a variable for that first. This will hold our command. We could just copy and paste our working command, add in double quotes. That's fine, it's not formatted correctly. So this file path is just this constant. We don't need these caret symbols. The rest of the command needs to go inside double quotes. Remove the caret, end double quote and move to a different line. Start a double quote again. Let's just move this to the right. So this is our output file path, which is the output path. append it to a string. To preserve this double quote in the string, we need to add in 2 more double quotes. Same here. That's our input file path. And 2 more double quotes. Okay, no red line, which means VBA is accepting this, which is good. So with the command string ready, we now need a way to execute it from VBA. For this, we will use a shell object. Our class name will be wscript.shell. So this shell object, which is specifically created using wscript.shell, will act as a bridge between our VBA code and the Windows operating system. It will allow our Excel macro to run external programs or execute command line instructions just as if we were typing them into a command prompt. And finally, we will execute the command using the shell.run method. We'll feed in our command string, give an argument. 0 will hide the command prompt window, so basically keep it invisible to the user. And true tells VBA to wait for the GoScript conversion process to complete before moving on to the next line of code. This ensures that the PNG file is fully generated and saved before our VBA tries to send it to the Gemini API, preventing errors. And that completes our PDF to PNG conversion routine. I've discussed how to generate your API key along with all the fundamentals you need to know about the Gemini API in my previous video, so please refer to that for a detailed step-by-step guide. The link will be in the description, but for now, I'll just briefly show you where to get the API key from. So go to Google AI Studio. You may need to sign in, but for now, I will play a quick clip from my previous video on how to get the API key if you don't already have it. From your browser, let's visit Google AI Studio. You might be prompted to sign in. Click on Get API Key. Accept the terms and conditions. Find the Create API Key option, click on it. Our key has been generated. Copy. For this project, I'm going to save the API key in a separate module. So I've defined a constant for the API key, placed the key out here, and I've also created a constant for the API URL, which we can grab from Google AI Studio itself. And notice that the model that I'm using is Gemini 2.5 Flash. AI models are always being updated, and you can find the correct API endpoint URL for any model in the official Google AI documentation. Back to our code. Let's build the function to call the Gemini API. This function will take the path to an image file, prepare it, send it as a request to the Gemini API, and then return the raw JSON response that we receive back. So the parameter will be the full path to the image file, and we'll return the response as a string that we'll eventually have to pass through. And we'll talk more about them as we reach that particular part in the code. Let's declare some initial variables. The Gemini API expects images to be sent as base64 encoded strings within the JSON request. To do that, we will use a helper function. In fact, there are 2 helper functions. I'm just going to paste the entire code below for them. So this is function 1 and this is function 2. We'll return back to what these functions are doing. For now, let's just continue with creating our API call. So the encode image to base64 function will read through an image file, convert its binary data into a base64 string, and we'll store that data in a variable. Next, we'll construct the body for a request that we will send to the API, and we'll store it in this variable. Again, I'm just going to copy and paste because there is no way I will type this out without making a mistake. So what we are constructing out here is basically a JSON that will look similar to this. For sending this JSON data through VBA, we need to package this as a string. So what we are doing in our code is enclosing this JSON inside 2 double quotes. And for each existing double quote within the JSON, we escape it with another double quote. And that's how we continue on till every existing double quote has been accounted for. And the other thing that we do is flatten this out into a single line. I'm not going to do that, but the result would look like this. And notice out here, we have a placeholder for sending our image data. In our VBA code, we exit our string using the ampersand symbols and place in our variable for the image data that we have generated out here. And for the actual prompt, we have hard coded it into a string. And this is one thing to be aware of. If you want to change this prompt, add another field, or use a completely different scenario, you will need to come here and change it within the code. Or as I've done in my previous video, we write the prompt in a cell in Excel, grab that cell data into a variable and paste that variable into a JSON string. Let's continue and build out the rest of a function. To use VBA to make HTTP requests to web services, such as the Gemini API, we need to create an instance of this win HTTP object. And the way to do that is use the create object function. And we'll assign it to the HTTP object that we have defined above. So let's open the connection to the API endpoint. We will specify that it's a post request, which means we are sending information. We will send our URL along with the key. And set false to indicate that this is a synchronous request, meaning that VBA will wait for the response before continuing to the next line of code. We need to send some more information along with this request in the form of a header. So this content type header, we are setting it to application JSON, which indicates to the API that the data that we're sending it is in JSON format. And all of this setup is basically this setup from the original documentation translated into VBA. If you're not yet comfortable with this setup, I would suggest trying out my previous video where we don't actually send any image, we just send a prompt, which means it's a simpler request. And we also walk through this setup in more detail. Anyways, it's time to send our request. Using the send method, and we need to send our request payload. And finally, after the Gemini API processes a request and sends back a response, we will capture that response text and assign it as the return value of our call Gemini function. So this will be the response. Okay, that completes our function to call the Gemini API. It's now ready to send our image data along with our prompt to Google's Gemini AI and receive the extracted information. And to handle the base64 encoding, we have used these two standard helper functions. Let's quickly touch upon what they actually do. These are standard procedures often used in VBA when you need to handle binary data and send it over the web. So on a high level, this first function takes the image file. Its primary role is to read the raw binary data of that image file so that it can be processed further for the actual base64 encoding. And it does this by passing this binary data to our next helper function. This function takes the raw binary data as a byte array and then transforms it into a text-based base64 string. And this base64 string is crucial because web requests can't directly send binary files. They need their text-based representations. Again, this is just too much detail. You don't need to understand every line of what these functions are doing. These are common helper functions for base64 encoding in VBA, and you can easily find these functions online, or even better, you can prompt a large language model like Gemini itself to generate them for you. So let's actually do that. So here I'm in Gemini, I'm using the 2.5 Flash model. Let's ask it to generate the two VBA functions for us. I'll paste in my prompt. So the prompt says generate VBA functions to convert a file path to a base64 string, include any necessary helper functions, and make sure it works with binary data like images. And I've just specified that do this using two functions so that it returns back something similar to what I have in my code. Okay, and we have our two functions. Here's our first one and here's the second one. The second one uses the exact same object to do the base64 encoding as what I have out here. And the first function also does the same thing, but takes a different approach, which is fine. This function just uses the native VBA IO operations to read the file, while I use add upstream, which is part of the ADO library. Again, really doesn't matter which method is used. They will all do the same thing. We will return our focus to the wider workflow, which is to now pass or read the response that's been sent back to us by the API. Before we continue, this is a good point to test and see whether our code is working. So what we will do right now is call this function. We'll just call it directly. So I'll just create a separate test sub for this. We'll directly paste in the path to one file. So I'm giving it an image file directly. Let's print out the response. Okay, let's play the macro. Fantastic. Rookie mistake. It's set. Stop. Play the macro again. Something's printed out in our immediate window. Let's bring this up. Looks like we have a response. Let's just copy this response into Notepad++. As you can see, this raw response from Gemini is a bit messy. It wraps the actual JSON data that we want inside a larger JSON structure. So we need a way to pass this JSON and extract just the clean data that we want. And for that, we will use a popular open source library called JSON Converter. So let's go to GitHub. There is some good useful information out here on how to use it. You could ask Gemini or ChatGPT as well. But on a high level, there are 3 steps out here. We need to download the latest release, import the file into our VBA project, and then to actually use this converter, we need to set a reference to the Microsoft scripting runtime library. So let's do that. We will grab the zip file. I'll paste it into a folder. Extract the file. So we need to import this .bas file into our VBA project. Let's do that. Go to File, Import File. Open. It opens up in a new module. Get the immediate window down. Here's all the source code for it. And the last step is to set a reference to the Microsoft scripting runtime library. Scroll down till you see M. That's it. Okay. And now that we have this library or set of functions installed, we can build our own function on top of it to extract the text from the Gemini API response. But basically what we're going to do is, for starters, call this pass.json function. Let's do that. Let's create a function. Actually, it should be a function because we want to return the clean response. It will take the raw JSON response directly from the Gemini API and extract only the clean structured JSON object containing our invoice data. And even though it's a JSON, we're going to still represent it as a string. Let's define some variables. Our first step will be to use the JSON converter to parse the entire raw JSON response. I won't forget the set this time. So here we're referring to this module and we'll call the parse JSON function, passing in the raw JSON. And why is this an object? So if you go back to the JSON converter module, check out the parse JSON function, we can see that we are being returned an object. And this object is nothing but a dictionary, which kind of makes sense because that's exactly what a JSON structure is. It's just a bunch of keys and values nested inside each other. And the actual invoice data that we are interested in is nested deep inside the Gemini AI response. So the way to navigate to this value would be, we'll grab the value and put it inside this variable, call the dictionary object. The outermost key that we are after is candidates, and the value that's assigned to this key is actually an array. And we know that because it starts and ends with squared brackets. So let's go into the candidates array, select the first item, which is at index 1. This goes into content. Content contains another JSON, so we'll access the key paths. Paths contains an array, so we'll access the first element. The first element is a JSON, so we can directly access the text key. This line will precisely extract the string that contains our desired JSON. Actually, let's test this out. I will use my old test sub for this. And now, instead of assigning R, the raw JSON that's returned by the call Gemini API function, we will feed the value from this function. Let's just make some quick changes. So the call Gemini API will return the raw response. The clean response will be returned by the function call where we feed in the raw response. What we need to do here though is return the value back to our function. We'll return the trimmed value. So previously, when we printed out this variable, we got the entire JSON response. Now, what we are hoping for is our actual prompt response returned by the AI, which should be all of this. Let's run a sub. We get a type mismatch error, which is, let's see what it is, debug. It's in this line, probably mistyped something. Quickly look at the original JSON. Everything is in lowercase. I think this is case sensitive. So let's do that and resume the macro. Oh yeah, we get a response. So that's the JSON that we are after, but it's wrapped inside all of this text. Let's remove that first. What we can do is do a couple of replace functions just to replace this first part and the last part. Just grab it from the immediate window just to make sure I don't do any spelling mistakes. This last part is just the 3 backticks without the JSON. Okay, clear the immediate window. We can actually test this out again while we're at it. Silly mistakes. Okay, I've told you to replace, but I've not told it to replace with what. Let's do that. Okay, resume the macro, and we get the actual JSON structure that we're after. And you can guess what the next step is. We gotta now use the same JSON converter to parse this final response and grab the values for the invoice number, date, total, and supplier and paste it into our Excel sheet. Let's do that next. All right, so far we have our clean extracted JSON string containing the invoice details. Now we need a subroutine to take this data and write it neatly into our Excel sheet. Let's build that subroutine. It'll take one parameter, which is a clean JSON string. This time we're just going to be performing an action, which is taking the JSON and writing into our Excel sheet. We're not going to be returning anything, and hence we're using a sub and not a function. Let's declare some variables. Next, we'll call the same JSON converter pass function. Actually, we're performing this exact same step. So let's just copy that because I think I've used the same variable name. The only thing we need to change is pass in our clean JSON. Let's find the next available row in our Excel sheet because we're going to paste data one below the other. And in a very final step, we will write the extracted values into the respective columns. Since it's a dictionary, we will access the first key. Actually, I don't want to type this out. What I will do is just run this sub again. I want the clean extracted JSON so that I can copy and paste the headers. I shouldn't have deleted it in the first place. It was good to have a reference while building out this last part. But anyways, copy this, paste it here. So that's going to go in column A. We're going to do the same thing 3 times for the date in column 2, total in column 3, and supplier in column 4. And that's it. We've built our entire code base in a modular format wherein we've built each individual functions or subs. Now we need to go and call it back from our main sub and fill it in against each of our case paths. But one thing I want to mention here, we have hard-coded invoice number, date, total, and supplier out here. If you wanted to change this and extract some other kind of information, for example, if you're looking at purchase orders or marked sheets or survey responses, you would need to do just 2 things. Change the column headers out here and define this, or rather this JSON structure in our prompt. Where's the prompt gone? In our prompt out here. And I noticed one more thing. We have a preparation module as well. So you would probably have to replace these values. So it's not ideal. I would rather have this more dynamic. So basically have a prompt out here, something like this. And our VBA code should be smart enough to read these field names, place them into the headers, and then dynamically call on each field name when passing the clean JSON. But that's just extra enhancements and it would take away from what we are building out here. But anyways, now let's go on to the final part where we put everything together. Now, just as a summary, so far we have built our code as individual functions and subroutines. Now, let's integrate them into our select case block within our main subroutine. We'll start by handling these PDF invoices. When the file extension is PDF, our first action is to define a temporary path for the PNG image that the Go script will create. Let's do that. We'll save the file in the invoice folder and replace the PDF extension with a .png extension. So we're just going to temporarily store the PNG file out here. Next, we'll call our Go script conversion routine, which is this one right here. We need to submit the PDF path, which is just the file path here, and the destination path, which is this one out here. So just to recap, this subroutine will pick up the invoice PDF from this file path and convert it into a PNG and save it in this file path. And now that we have a PNG file, we can send it to the Gemini API and then clean the response. So get the raw response back from the Gemini API function, which will take in the image path, and we'll store the clean JSON out here, which we will do by extracting the clean JSON by submitting the raw response. Okay, we'll just put in a basic error handler and check if this clean JSON is not blank. If it's not blank, we will write the data to our worksheet. Move the original PDF to the done folder. Saving it as the same file name. And for the final step, for the PDF invoices, let's delete off the PNG file that we had created out here. That's it for PDFs. And for image files, we don't need to convert it into an image because it's already an image. So we will just perform all these steps again with a few minor modifications. The image path will just be the file path because the file is already an image. And then we'll do the same thing. Call the Gemini API, get the raw response, call the extract function, grab the clean JSON, check whether the clean JSON is not empty, and then write the data onto an Excel sheet, move the file, and this time we don't actually want to delete the file because it is the original copy. So we'll remove that part. And we have the case else block for any other file type. This block handles any file in the invoice folder that is not a PDF, PNG, JPG, or JPEG. We don't want our loop to error out on unsupported file types, so we'll use a goto statement. So this will jump the code execution to the continue loop label, which will effectively skip the rest of the processing for the current file and move to the next file and the next iteration of the do loop. And that's it. Our entire VBA macro is now complete. Let's run a full test. So we're going to run the same flow that we saw in the demo earlier. We have a JPG file, a PNG file, and 3 PDFs. Let's just clear off all the data from my Excel sheet. One thing to do is insert a button because that's how we had it in our demo. Call our main sub. Okay, I'm going to save the file and let's run it from here. And we have an error, which is expected because we wrote so much code. Debug. Let's see what the issue is. I think I've messed around with the settings. In my options, this one should have been checked. Anyways, the issue out here is that we haven't really defined what this is. It is our invoices worksheet. Okay, we need to stop and run it again. Stop, run the macro. All right, that looks promising. And that's done. One final check is to make sure that all the invoices have moved from the invoices folder to the done folder. We have 5 here. So we retained the original copies and all the image files would have been deleted. And that's a wrap for this video. I hope you enjoyed building this powerful automation with me. Thanks for watching and I'll see you in the next one.